Dear students, today we will discuss about dimensions and dimensional formulae. So, how to find the dimensional formula of a physical quantity? You know what is physical quantity, that we have already discussed, and what is the dimension? Just try to find out the answer. So, I will discuss the dimensional formula. So, dimensional formula of a physical quantity tells us or gives us some information. What information it gives us? If, let us say, talk about the dimension formula of speed. This is m0 L1 t minus 1. How it comes like this, that we will discuss. But what is dimensional formula and what information the dimensional formula gives you? Let us discuss that first. So this is the dimensional formula for the speed. So here, what information it is giving you? That the speed is consisting of length only and time only. That means to express this speed in dimensional formula, we need length and time. And how it is being, how many times the length is being used? Because mass is not being used, because m0 mass is not being used, the length is being used once, and similarly the time is being used once again. And what they are being, whether they are being multiplied or divided, this information is also obtained from the dimensional formula. So here, since the power of length is plus and the power of time is minus 1, that means the information is obtained here, the length is being divided by the time. So the speed, to express the speed, we need length once, we need time once, and the length is to be divided by time. So all this information is given by or obtained from the dimensional formula. So how to derive or how to get the dimensional formula of a physical quantity? So let us say we have the fundamental quantities. We have already discussed it. So there are fundamental quantities: the length, time, mass, temperature, electric current, that we use the symbol A in case of dimensions. Then we have candela, the luminous intensity, and amount of substance, that is mole. So these are the 7 fundamental quantities, and in terms of these we express a physical quantity. So let us say we talk of the wavelength. Here we will have the physical quantity, and here we will have the dimensional formula. So the wavelength is actually the length. So the dimensional formula for the wavelength will be m0, L1 and t0 only. Then we go for the speed. The speed is distance upon time. So distance is nothing but the length and upon time. So the dimensional formula will be, mass is not being used, length is being used once, and time is also divided by, so this is minus 1. So then velocity. Velocity is displacement upon time. Displacement upon time. So displacement is again length. So here it is again m0 L1 t minus 1. Now the acceleration. So acceleration acceleration. So that is A equals to velocity upon time. So we have the velocity this and this to be divided by time. So where we'll have m0 L1 t minus 1 divided by t. So the power goes up. So we get m0 L1 t minus 2. So this is the dimensional formula of acceleration. Now the force. So force F equals to ma. So to find out the dimensional formula, you must be knowing, or you must know the different formulas relating to this particular physical quantity which you need to convert in a dimensional formula. So that means these relations must be known to you. Then and only then you will be able to derive the dimensional formula for that. So most of the time we have discussed already the derived quantities. So how the different derived units and derived quantities. So derived quantities are obtained by simple multiplication or division of different basic quantities or fundamental quantities. So those formula you must remember. So before starting this dimensional formula, practice to derive the derived quantities from the fundamental quantities. Once you will be very much familiar with those derivations of the derived quantities, then this dimensional formula will become very easy task for you. So mind it. So this is F equal to ma. So mass is there and acceleration is m0 L1 t minus 2. So then it becomes m1 L1 and t minus 2. So this is the dimensional formula for the force. The mass is to be multiplied with the acceleration. So the dimensional formula for the acceleration is this. So multiplying mass, so you will get 0 plus 1. When according to the law of indices, once you are multiplying the two quantities, then the powers are added. So here the power of m is 1. So 0 plus 1 is 1. So you will get m1 L1 t minus 2. Now you can have density. So density is mass upon volume. So here you can have mass is m1 L0 T0 and the volume is m0. How many L? Length into breadth into height. So breadth is also length, height is also length. So it is L power 3 and there is no time. So therefore the power of the m is 1 minus 0 is 1. Then the power of length is 0 minus 3 according to the law of indices. So that is minus 3 and then t 0 minus 0, that remains 0. So this is the density. The dimensional formula for the density is m1 L minus 3 T0. Now the dimensional formula for pressure. The dimensional formula for pressure is force upon area. That means the force is m1 L1 T minus 2. This is the force. Here m1 L1 T minus 2 divided by the area. So in this case area is m0 L2, length into breadth, that is L2 and T0. So we have m1 L minus 1 and T minus 2. So this is the dimensional formula for the pressure. What is the dimensional formula for the momentum? Momentum. So momentum P is m into V. That means you must be well versed with the different formulas. So mass into velocity. So mass is m1 L0 T0 and velocity is m0 L1 T minus 1. So after multiplying this, what will be this? M raised to power 1. Very good. Then L raised to power, yes, it is 1. T raised to power 0 minus 1 minus 1. So the dimension for momentum is 1 L T minus 1.